Let us look at conjugate of a complex number. We have seen if an equation with real coefficients has a complex root, then its conjugate is also a complex root. A conjugate of z equal to a plus ib is z bar is equal to a minus ib. Now let's look at some properties. The product of a complex number and its conjugate is a real number. That is z times z bar is in real numbers. So let's see. Let's multiply a plus bi times a minus bi. Opening up the brackets, we can directly look at it from the identity point of view, or we can expand it. The middle two terms cancel out and we are left with a square plus b square. Now, by definition, in a complex number, a and b are real numbers. So, which means the sum of their squares is also a real number. Let's plot it. So, here we have a as the complex number. Let's put it somewhere here. And its conjugate would be here. So, as I move it, its conjugate will also move, and it will always be a reflection on x-axis. Okay, let's say this is the origin, and let's join these points to the origin. The product z times z bar, let's plot it. It's a real number, and as I move it, that will keep changing. Doesn't matter where I take it, it will always be a positive number. Let's look at the second property. The ratio of a complex number a plus bi to its conjugate is real if and only if a times b is equal to 0. So what does that mean? Either a is equal to 0 or b is equal to 0. So z by z bar is equal to a plus bi divided by a minus bi. Let's rationalize the denominator. We get a square plus 2abi plus b square I square by a square plus b square. And simplifying it, we get a square plus 2abi minus b square divided by a square plus b square. If a is equal to 0, then a square plus 2abi and a square in the denominator becomes 0. We are left with minus b square by b square, which is equal to minus 1. And if b is equal to 0, then a square by a square we are left with, which is equal to 1. Let's plot it. We have this point. Let's join it. Now notice that as I move z by z bar goes in a circle with radius 1. And when a is equal to 0, here it is minus 1. When b is equal to 0, anywhere on the x-axis, we get z by z bar equal to 1. Now let's look at third property. We have already seen in property 1, z times z bar is equal to a square plus b square. Since the modulus of z is equal to square root of a square plus b square, we have the square of the modulus is equal to a square plus b square. So which means z times z bar is equal to the modulus of z square. Now fourth one, modulus of z1 plus z2 is equal to modulus of z1 plus modulus of z2, or in English, the conjugate of a sum is the sum of the conjugates. Now this can be very easily proved by using A plus BI and C plus DI. Similarly, the conjugate of a difference is the difference of the conjugates. Again, the conjugate of a product is a product of the conjugates. Conjugate of a quotient is the quotient of the conjugates. Here, in the second property, the ratio of a complex number A plus BI to its conjugate is real if and only if A times B equal to 0. So, here we have shown one part of the proof. So, prove if A is not equal to 0 and B is not equal to 0, then A plus IB by A minus IB is not in real numbers. And prove the properties 4 to 7 using Z1 equal to A plus BI and Z2 equal to C plus DI. Pretty straightforward things. Nice to do a little practice. That's it for now.